In this video, we are going to make a Sudoku game. You don't need to download any assets since we are building this from scratch. This is a beginner-friendly tutorial where I will be explaining everything step by step. If you are not able to follow at some point, please do comment. I am happy to help. To begin, you need to add a control node. The control node helps you place the GUI elements you need, such as buttons. Rename this control node to Game. Add a child node. Color rect. This node is used to give a background color. For now, I am using black. Add another child node. Center container. This node is used to align items in the center. Inside that, add a GridContainer node. This GridContainer is used to represent the squares in Sudoku. Since Sudoku has 9 columns, set the columns property to 9. For the main nodes, set the anchor to full rect, so that they take up the full screen. Now, save the scene and create a script for the game node. First, we need to set our variables. Hold the Control key, click and drag the GridContainer node into the script. We need this reference to add buttons later. Then, we will have an array called board_data that will hold the current values in the Sudoku grid. We will also have another variable called starting_board, which represents the initial board layout before the game starts. For now, I am filling everything with zeros. We also need a variable called selected_cell to track which button the user has clicked. Now, we need to add a function called create_board to generate the play area. In this function, we will loop from 0 to 80, since Sudoku has 81 squares. Button.new will create a button in memory to represent the numbers. In our array, if the value is 0, it indicates there is no value yet. So, we add an if condition to ensure the button handles this correctly. If the value is not 0, we set the button text to the string value of the starting_board and make the button disabled. We disable it because we don't want to change the values that are initially set in the puzzle. After that, we make sure board_data matches the starting_board value. We also set a custom minimum size for the button. Finally, we add this button to the GridContainer. We repeat this to add all 81 buttons. The _ready function is called once at the start. In the _ready function, we resize the board_data array and initialize it to zeros. Then, we call create_board to actually display the grid. Now if you run the scene, you can see the full board. Now, you need a function to track the latest selected cell. Create a function that takes the button as an argument. First, it checks if selected_cell is not null. If it isn't, we revert its color to white. We do this because later we will add a color highlight, and we need to ensure the previous highlight is removed when the selection changes. Then, we update the variable to the new selected button. For testing, let's add a print statement to check if the code is working. If we run the scene and click a button, you can see the button clicked message appears. Right now, you can't enter any numbers. Our next step is to take numbers from the keyboard and display them on these buttons. First, go to Project Settings and then Input Map. Here, we need to add actions for numbers 1 through 9, and map them to the number keys 1 to 9 on the keyboard. After that, in the _process function, we create a dictionary to map the input action names, like 1, to the actual integer values, like 1. This makes the code cleaner. We iterate through the keys, and if an input is pressed, we handle it. To handle input, we create a separate function called handle_input. It first checks if there is a selected _cell. If yes, it changes the button text to the newly typed number. Along with that, we also need to update the board_data. Now if we run the scene, we can actually see numbers appearing on the screen. Our next step is to check if the number is valid based on Sudoku rules. For those not aware, in Sudoku you need unique numbers in every row, column, and within each of the 9 3x3 boxes. A number cannot be repeated in those areas. If you fill all numbers following these rules, you win. To implement this, we create a function called is_valid_move. If you are new to programming, this function might be a little hard to understand at first. If it feels difficult, just type it into the editor as is and analyze it later. The function takes the cell underscore index and the number as arguments. The cell underscore index tells us which button number we are on. To traverse the grid, we need to find the specific row and column. If we divide the index by 9, we get the row. If we use the modulo operator, remainder, we get the column. After that, we run a for loop. First, we check the row. If the number is already present in that row, we return false. To check if this works, we call the function. If it returns true, we update the selected underscore cell and board underscore data. Otherwise, we reset the data for both. As you can see on the screen, it prints invalid move if I try to place the same number in a row. Next, we traverse the column. Similarly, if we select the same number in the same column, we get an invalid move. Lastly, we need to check the 3 by 3 boxes. First, we identify the top left corner of the box the current cell belongs to. Then we iterate through that specific box. If we find a match, we return false. Otherwise, we return true. The code is working fine. We also need to make sure we are excluding the current selected underscore cell from this check, since we only want to compare against other numbers. We can also change the color if the move is invalid. We also need to unselect the cell if we click outside the grid, on the background. Connect a signal to the background node, checking for a generic mouse event. If clicked, set selected underscore cell to null and release focus so the highlight is removed. Now if we run the scene, it should work perfectly. Finally, we need to provide a UI interface. Add a start button and 2 labels. Select the button and type start in the text property. Increase the font size and center it. Change the text of the label to Sudoku and position it. Connect the signal for the button. When clicked, we create the board and hide the start button. We also need a function to see if the player has won. We iterate through board underscore data to check if every number is filled, non-zero. If every number is filled, we display a U1 message and change the background color. Now we can change the starting underscore board variable to use actual Sudoku puzzle values and play. This is our Sudoku game. You can extend this or use different methods to implement it, but our goal here was simply to learn.